Class 11th Chemistry, Unit 3, Classification of Elements and Periodicity in Properties. And in this video, we will discuss about types of elements, S, P, D, F, blocks, elements. Depending on the type of atomic orbitals that are being filled with electrons, the elements can be classified into 4 blocks, namely S block, P block, D block, and F block. There are 2 exceptions to this categorization. First one is helium. Electronic configuration is 1s2. Belongs to the S block because last electron enters S subshell. But it is placed in the P block along with other group 18 elements. Why this is placed with the group 18 elements? Because it has a completely filled valency shell and as a result exhibits properties characteristic of other noble gases. Other exception is hydrogen. It has only one s electron and hence can be placed in group 1, that is alkali metals. It can also gain an electron to achieve a noble gas arrangement and hence it can behave similar to a group 17 elements, and group 17 elements are known as halogen family. Because it is a special case, we shall place hydrogen separately at the top of the periodic table. Now you can see classification of elements into blocks and just see the position of hydrogen. This is placed separately. These are S block elements, these are P block elements, and in between these S and P block, these are the D block element, and at the bottom of this main periodic table 2 series are there. And these are F block elements. Okay, now we'll discuss one by one. First come to the S block elements. Outermost electronic configuration is NS122, that is last electron enters S subshell. The elements of group 1 and group 2 belongs to the S block elements. Group 1 elements known as alkali metals. Outermost electronic configuration is NS1 and lose 1 electron and form uni-positive ion, that is M+. The group 2 elements, these are known as alkaline earth metals. Outermost shell electronic configuration is NS2, lose 2 electrons and forms di-positive ion, that is M2+. They are all reactive metals with low ionization enthalpy. Now, what is the meaning of this ionization enthalpy? This is the energy required to lose outermost shell electron. Okay, and they can lose electron easily. That's why their ionization enthalpy is low. The metallic character and the reactivity increases as we go down the group. Because of high reactivity, they are never found pure in nature. They always occur in combined state. The compounds of the S block elements, with the exception of those of lithium and beryllium, are predominantly ionic. Actually, the compounds of lithium and beryllium have covalent characters and remaining have ionic characters. How to remember? How can we remember these elements? That is mnemonics for the S block elements. Now, what is the meaning of this mnemonics? It is a word or sentence or poem used to help remember a rule, name, etc. Okay, just see, this is group 1 elements. These are the atomic numbers: 3 lithium Li, atomic number is 11 sodium Na, 19 potassium K, 37 rubidium Rb, 55 cesium Cs, 87 francium Fr, and these are the mnemonics. It is लीना की रब से फरियाद, लीना Li Na, lithium sodium, K potassium K, रब Rb rubidium, से Cs cesium, फरियाद Fr, लीना की रब से फरियाद, Li Na K Rb Cs Fr. Group 2 elements. Atomic number is 4 beryllium Be, 12 magnesium Mg, 20 calcium Ca, 38 strontium Sr, 56 barium Ba, 88 radium Ra. And how can we remember? This is beta mange car scooter baap raji. Beta Be, mange Mg magnesium, car Ca calcium, scooter Sr strontium, BAP, BA, barium, Raji, Ra. Okay. P block elements. Elements of group 13 to 18 belongs to the P block elements. The outermost electronic configuration NS2 NP126. Last electron enters P subset. At the end of each period is a noble gas element with a closed valency shell, that is NS2 NP6 configuration. The noble gases exhibit very low chemical reactivity. Preceding the noble gas family are two chemically important groups of non-metals. That is, before noble gases, two groups are there which are chemically important, and they are halogens, group 17, and chalcogens, group 16. These two groups of elements have high negative electron gain enthalpies. Now again, what is the meaning of this electron gain enthalpy? This is the change in energy when electron is added to neutral atom to make it negatively charged ion. That is known as electron gain enthalpy. And for these elements, high negative electron gain enthalpy is there. And readily add 1 or 2 electrons respectively to attain the stable noble gas configuration. The non-metallic character increases as we move from left to right across a period, and metallic character increases as we go down the group. Non-metallic character increases from left to right, and metallic character increases from top to bottom in a group. The S and P block elements together called representative elements or main group elements. These are the mnemonics for P block elements. Group 13 elements, boron family. First member is boron B, aluminium Al, gallium Ga, indium In, thallium Tl. Mnemonics: Bengan, Alu, Gajar, in, Thela. Bengan B, Alu, Al, Gajar, Ga, indium in, thallium Tl, Thela. Bengan, Alu, Gajar, in, Thela. Bal, Ga, In, Tl. Group 14 elements, carbon family. First member is carbon, then silicon Si, germanium Ge, tin Sn, lead Pb. Cassie Ho Ji, son of pub. Cassie Ho Ji, son of pub. K, carbon. C, Si, and this is used to complete the sentence. Ho, okay. Ge, germanium, son Sn. Again, this of is used to complete the sentence. This is Pb, pub. Cassie Ho Ji, son of pub. Carbon, silicon, germanium, tin, and lead. Group 15 elements, nitrogen family. These are also known as nitrogens. First member is nitrogen, then phosphorus P, arsenic As, antimony Sb, bismuth Bi. And mnemonics: नहीं पसंद ऐसे सब भाई, नहीं पसंद ऐसे सब भाई, नहीं and nitrogen, पसंद P, phosphorus, ऐसे As, arsenic, sub Sb, antimony, भाई Bi, bismuth. Okay. Group 16 elements, oxygen family. These are also known as chalcogens. First member is oxygen. After that, sulfur S, selenium Se, tellurium Te, polonium Po. Mnemonics: Os se tipo. Just make a sentence. Os, oxygen, sulfur. Se, Se, Te, Po, polonium. Os se tipo. Group 17 elements, halogen family, also known as halogens. First member is fluorine, then chlorine, bromine, iodine, astatine. Mnemonics: फिर कल बहार आई आंटी, फिर कल बहार आई आंटी. फिर F, fluorine, कल Cl, chlorine, बाहर Br, bromine, I, iodine, aunty, At, astatine. Group 18 elements, noble gases. First member is helium, then neon, argon, Ar, krypton, Kr, xenon, Xc, radon, Rn. And mnemonics: Hini और करजी run, Hini और करजी run. He, He, helium, Ni, Ni, neon, or Ar, argon, Kar, Kr, krypton, G, Xe, xenon, run, Rn, radon. These are the mnemonics used by me. You can also make your own. Okay. D block elements, transition elements. These are the elements of group 3 to 12 in the center of the periodic table. That is in between S block and P block elements. These are characterized by the filling of inner d orbitals. Inner d orbitals means n-1 d orbitals by electrons and are therefore referred to as d block elements. These elements have the general outer electronic configuration n-1 d 1 to 10 ns 0 to 2. They are all metals. They mostly form colored ions, exhibit variable valency, that is more than one valency, and valency is also known as oxidation state, but there are the differences between valency and oxidation state which we will discuss in later chapter. Paramagnetism. Now what is the meaning of this paramagnetism? They attract towards external magnetic field. This property is known as paramagnetism and oftenly used as catalyst. I think you are familiar with this word catalyst. These are the substances which enhance the rate of reaction. However, zinc, cadmium and mercury with electronic configuration N-1 D10 NS2 do not show most of the properties of transition elements. Okay, actually transition elements are defined as elements which have partially filled d orbitals in their elemental state or in their ionic form. Okay, partially filled d orbital. If you see the electronic configuration of these elements, in these elements d subshell is completely filled. Okay, zinc in the atomic state, this is D10 NS2. Okay, and in its ionic form, zinc is exists as Zn2 plus, and in Zn2 plus this also has, this is 3D10. That's why zinc, cadmium and mercury are placed with the d block elements, but they are not considered as transition elements. In a way, transition metals form a bridge between the chemically active metals of S block elements and the less active elements of groups 13 and 14, and thus take their familiar name transition elements. And these are the 4 series of transition elements or d block elements. That is 3D series. That is last electron enters 3D subshell, starting from atomic number 21 scandium and end zinc atomic number 30. 4D series, 39 atomic number yttrium, last element is cadmium 48. 5D series, 57 lanthanum. Okay, and after lanthanum there are 14 elements belong to the lanthanoid series, that is F block elements. And then atomic number 72 hafnium 2, atomic number 80 mercury. 6D series, 89 atomic number actinium, and after actinium again 14 elements belong to actinoid series. Again these are the F block elements. And after that Rutherfordium atomic number 104 to copernicium 112. But first series is more important. That's why try to memorize the name, symbol and atomic number of these elements. And again we use the mnemonics. Scandium Sc, titanium Ti, vanadium V, chromium Cr, manganese Mn, iron Fe, cobalt Co. Again Co, C is capital and O is small. Don't write both capital, otherwise it will be carbon monoxide. Nickel Ni, copper Cu, zinc Zn. And if you see the atomic number, this is increases from 21 to 30. Now how can we remember these elements? This is Shakti, Vikram, Fekoni, Kujan. Shakti, Vikram, Fekoni, Kujan. Shakti, SCTI. Vikram, V, vanadium, Cr, chromium, M, manganese, Mn. Fekoni, Fe, iron, Co, cobalt, Ni, nickel. Kujan, Cu, copper, Zn, Zn, zinc. Okay, and these are the electronic configuration we already discussed. The F block elements, inner transition elements. The two rows of elements at the bottom of periodic table are called F block elements. The outer electronic configuration N-2 F1 to 14, N-1 D0 to 1 NS2, and these are the two series of these inner transition elements. lanthanoids 4F series. That is, last electron enters 4F subshell, starting from cerium atomic number 58 and up to lutetium atomic number 71. Another series is actinoids. That is 5F series, starting from thorium atomic number 90 and up to lawrencium atomic number 103. They are all metals, and last electron added to each element is filled in n-2 f orbital. And for lanthanoid we can say n is equal to 6, and for actinoid n is equal to 7. Okay. Within each series the properties of the elements are quite similar. Actinoid elements are radioactive. That is, these are the elements which emit alpha, beta and gamma rays. Many of actinoid elements have been made only nanogram quantities or even less by nuclear reactions, and their chemistry is not fully studied. The elements after uranium are called transuranium elements. Okay student, subscribe my channel to get the new videos of this chapter. Thank you.